Yeah, I'm sorry, everyone. Let's start off. Hope everyone has gone through the notes. The last class we did with centromas of different shapes. Let's go ahead. Let's do more questions on this. Let's say we have a solid cone. At the bottom, we have a solid hemisphere. Now I should know the centromas of cone and hemisphere. Hope you guys remember. Solid cone का centromas is h/4 from the base. Hemisphere का centromas is 3r/8 from the base. Both have same density. So they're made of same material, so density is same. This point is your origin. The radius of hemisphere is r and the height of the cone is h. Find the center of mass. Okay, let's see. Hope the question is clear, everyone. Let's see. So for the solid cone, the center of mass will be somewhere here, which is at a height of h/4. And let the mass be m1, which is density into volume 1/3 pi r square h. Hope you remember volume of a cylinder. The center of mass of a solid hemisphere is 3r/8. Right, so if I then let the mass be m2, which is density into volume 2/3 pi r cube. So basically the center of mass will be 0, minus 3r/8. This center of mass will be 0, h/4. And done. So you have replaced this entire cone with a particle and the entire hemisphere with a particle. X coordinate is anyway 0, so the y center of mass will be m1h1. So m1 h/4 plus m2 minus 3r/8 by total mass. Substitute there and simplify, you're done. So this will be rho 1/3 pi r square h/4 minus rho 2/3 pi r cube 3r by 8. Pi r square ka term will go off, rho ka term will go off, 3 also will go off. So rho will go off, 3 pi r square. This will be h square by 4 minus 3 will go off here, r square, 3r square by 4 by h plus 2r. Okay, that's your center of mass. But this is not how they'll ask you. They'll ask you something even better. They'll ask you find the condition. Suppose if this thing is on a ground, they can ask a question like this. Find the condition for stable equilibrium. Now look at this. If h is greater than root 3r, you can clearly see the formula here, what we derived. If h is equal to root 3r, then the y center of mass also will be 0. So if the height of the cone is root 3 times the radius, the center of mass will be at the origin only, at the point where they meet. So if we take h is greater than root 3r, that means the center of mass will be slightly higher than the origin. Guys, I'm going to remove you guys from the classroom. I'll not tell you anymore. I'll just remove you from the classroom if the cams are not on. So if there is an issue, you should message me. After removing you, then you tell me there is a problem. I will think you're giving an excuse. So the center of mass will be slightly above the origin. So if you disturb this, now again, this slightly goes into rotation, but this is what will happen. The normal reaction will pass from here. Because your center of mass is here, the gravity mg will act from here. You can clearly see there is a rotational tendency. So the n will rotate this way, mg also will rotate this way. This body will rotate this way. Means if it displays to the right, it will also rotate to the right. What kind of thing is this? Unstable equilibrium. Means a slight disturbance and this thing will completely just fall onto the ground. Suppose if the height is less than root 3r, that means the center of mass will be below the origin, somewhere here. Now if you displace this, if you just disturb it, the normal reaction will be here. Mg will act somewhere here. You can clearly see it rotates back. Think about it. If I push it to the right, it comes back to the left. What kind of equilibrium is this? This is a stable equilibrium. Did you ever see these kids' car toys? You must have seen a toy like this. No matter how much you kick it, it'll always keep coming back. It'll always remain straight. Did you ever see a toy like that? This is how they manufacture it. They make the bottom a plastic disc. On the top, normally they keep a balloon. Something like this. If you keep a balloon, right, it's very lightweight, center mass is here. No matter how much you kick it, it'll always keep coming back. Never seen a toy like that? I've seen a toy like that. Or if you have seen Kung Fu Panda movie 1, in that, if you remember, there's a scene, this Po, right, the panda goes and actually in the gym, it hits a toy. It's like some toy kind of thing is there. So every time it hits, it just keeps coming back again, keeps coming back again. So this is how they manufacture the toy. Make the base heavier and the upper part light. If h is equal to exactly root 3r, So this is how they like ask in the exam. Find the condition for stable equilibrium. The center of mass is exactly here in the origin. If you displace this, so you have to disturb it, isn't it? That is how you know whether it is stable or unstable. If you leave it there, it will be there. If you disturb this, the mg and the normal reaction exactly will be on the same line. There's no rotation, stays there. So if you just disturb it and leave it there, it will stay there. Neutral equilibrium. So every position is stable, meaning every position it will remain at rest. It neither comes back nor goes away. There, we discussed this thing in work power energy. This is how you can put equilibrium here. So when you want to make kids ka toys, we generally make the base heavier. Clear with this? Center of mass and equilibrium. That's how you can play around with this. Any doubts on this? Clear with this, Pratyasha, Raunak?
Yeah.
Let's see one more.
Hello.
Arya.
Sir, so it does not matter like how much ever small force we apply. The in the first case, the object has to fall.
Yeah.
Okay.
You disturb it slightly, it will fall down. Matlab, if you actually hinge it here, na, this will become stable equilibrium when this becomes up and this becomes like this, aisa,
Yeah.
technically. So, but in this case, it will just fall onto the ground. ऐसा कुछ हो जाएगा.
Okay, sir.
Clear? Hmm. Let's see one more. We got a disk and we got a square plate. Same material. This is your origin. So this diameter is 2r, so radius is r, and this side is also 2r. Find the center of mass. They're made of same material. Let's get this. It is just solving there. You have to put the numbers and get it. There's nothing there. Hmm. Right, Samyak. No, Srihari. That is wrong. नहीं श्रीहरि राइट इश्मान नहीं होता ओके राइट आर्या नहीं वंशिका let's see now where is the center of mass for the disk. Center mass of the disk is here, which is minus r by 2 comma 0. The center mass of the plate is also sorry r comma 0. This is also r comma 0. This mass is m1, which is sigma mass per unit area into area of the plate. Masses are not equal, everyone. m2 will be sigma into 2r ka whole square. Radius is the r is the radius for the disk, and side of the square is 2r. Y coordinate is anyway 0. So x center of mass will be sigma pi r square minus r plus sigma 4r square into r m1 plus m2. Sigma r square will cancel everywhere. You will be ending up with 4 minus pi r by 4 plus pi. Check. That's your x coordinate. Y coordinate is anyway 0. Clear with this? The square plate has more mass than the disk, even though the center of mass coordinates look equal and opposite. Mass is more. Next one. This is a standard model. We got a disk with a cavity. So we got a disk and someone made a cavity like this. This is the center. This is your diameter. Basically, this cavity passes through the center and the circumference. Find the center of mass. You can take wherever you want origin. How do you do this thing? Now listen carefully this thing. How do you handle cavities? Now the trick that you're going to learn now, right? This is what we're going to use for every time whenever you see a cavity. And this thing keeps popping up multiple times. You will see again cavities at rotation. You will see cavities in electrostatics, gravitation, magnetism. You will see this in 4 or 5 chapters. So this is the thing that we do. So listen carefully. So whenever you see cavity, just fill it up. So if you have a cavity, this plus that cavity, if I just close it, I will get a full disk. Making sense? If I take that thing and fill it up, I'll get a full disk. What is the advantage of this? The advantage of this thing, I'll get something symmetrical whose center of mass I know. So let this center of mass be at x comma 0. I don't know where is that. This center of mass, I'm basically taking the center as origin. And this center of mass will be r by 2 comma 0. Agreed? You can choose anything as origin, it works out. Then what is the mass of this guy? So this mass of this guy is sigma into pi r square. This mass will be, let's say mass is m2, which is sigma into area will be pi r square by 4. Then what is this guy? M1 is nothing but m minus m2, the total mass minus the disk mass, it will be sigma 3 pi r square by 4. Now this is my argument. The centromass of this guy plus centromass of this small disk together should give you centromass of this full disk. Do you guys agree with that? If you fill up the cavity, it becomes a full disk. So the center of mass of the system will be m1 into x plus m2 into r by 2 must be m1 plus m2. That will be the center mass of the full disk, which is 0. m1 will be 3 pi r square by 4 sigma plus sigma pi r square by 4 r by 2. Sigma goes off, pi r square by 4 goes off, x is equal to minus r by 6. So preferably choose the center as the origin. That is always safe. You can choose whatever you want to origin. So examine normally the option should be like this. Where is the center of mass? Options will be like r by 3 from the center left, r by 3 from the center to the right, r by 6 to the right, r by 6 to the left. So they'll give options like that. Are you clear how we handle the cavity? Got this? Let's see one more like this. Same thing. Since you understood, let's do the something similar one. This time it's a solid sphere with a cavity. So unfortunately, the picture will look the same because I can't draw a 3D thing. This is a solid sphere with cavity. The previous one was a disk, 2-dimensional. This is also another standard model. The cavity again passes through the center and circumference. Find center of mass. I hope we by now you got the trick. Again, what is the catch? You take that solid sphere with a cavity. Then you fill up the cavity with another chota solid sphere. Then you'll get a full solid sphere. And remember, this is the concept. Like whenever you see a cavity, this is the first thing you should think of. Any model, this is how you handle. Because for the full sphere, I know the center of mass is at the origin. For this small sphere, I know the center of mass is r by 2, 0. For this big sphere, I don't know, let it be x, 0. If this mass is m, remember here mass is proportional to volume, so m is rho into 4 by 3 pi r cube. So if this is m, this will be m by 8 and this will be 7m by 8 because the radius is r by 2. Therefore, x center of mass will be 7m by 8 into x plus m by 8 into r by 2 by total mass is m is 0. We get x is equal to minus r by 14. Easy. Some people use the concept of negative mass and everything. You can do that, but I don't prefer because later on you'll have a problem. You will not understand what is negative mass and all that stuff. So keep it simple. You fill up the cavity, it becomes a symmetrical shape. Clear with this? You got the idea how to handle cavities. So let's do something a little similar one, but a little tougher. Let's say we got a square plate. So we got a square plate of Seidel and you removed a small square from the corner. And it is observed this corner, which is point A, the center of mass is at point A. So that small piece which you removed at the corner is the center of mass. The question, find the ratio of A by L if center of mass is at point A. A small square of side A is removed from the corner of a square plate of side L. And it is given this point A is the center of mass of the system. So after removing A, point A is the center of mass. Then what is the ratio of A by L? Hope the picture is clear, everyone. Anyone not clear with the picture, please ask me. Let's see. How do we start? Again, same story. You just go and so if you just take that small piece and put it back, you'll get a full square. So, but one thing I'll tell you, see, even though I removed that small piece, can you see there is a symmetry? If you draw a line like this, can you see left and right are identical? So choosing that line as x-axis will make your life little easy because I know then I need not find the other coordinate. So let's do that. So I will choose this as my line of symmetry. I will choose this as my origin. Right? I'll choose the center as an origin and something of this sort. So I will choose this as my x-axis. This is my y-axis. Great. And now if you look at the positions here, this length here is a root 2. And from the center, this length here is L root 2. That means this distance which I'm drawing in black line will be L root 2 minus A root 2, isn't it? No, that will be L by root 2, sorry, because it is half of the diagonal. That would be L by root 2 minus A root 2. Perfect. So the coordinates of A will be L by root 2 minus A root 2, comma 0. Any doubts on that? Just a geometry there. Are you getting it? So this is A root 2. This whole thing is L root 2. L root 2 ka half, so L by root 2. That is the coordinates of the plate with the thing removed. Now you're saying this plus this small square. If I add this, I'm going to get a full square. And for the full square, I know the center mass is 0, 0. What about the center mass of this thing then? It will be this point here. You can clearly see this is A root 2. So this length will be A by root 2. So this coordinates will be L minus A by root 2, comma 0. Hope you got that coordinate there. Sure with that? So this is L by root 2 and you subtract A by root 2. Then you get this coordinate here. Then what about the mass? So this mass will be sigma into L square. This mass let it be M2, which is sigma into A square. Then this mass will be M1, which is M minus M2, which is sigma into L square minus A square. There, I know the mass, I know the coordinates. I know the mass, I know the coordinates. I know the mass, I know the coordinates. Now, can you find A by L ka ratio from here? Try. I'll give you a minute or two. There, it's all geometry if you see. I did nothing about center mass here. Just give it a try. Anyone didn't get that coordinates part, please ask me. If you want a big picture, we can do that. This is what I did. So from here to this corner, this was L by root 2. This distance was A by root 2. This distance was A by root 2. Then this distance became L by root 2 minus A root 2. Because again, this distance is A root 2. So if you want this distance, then I should subtract L by root 2 minus A by root 2 will give you this distance, isn't it? Hope you're getting what I did. Let's get this. Now it is done. Once I got all this stuff, it is straightforward. Root 5. Yeah, right, Anita, you got it. Try it everyone, you got a minute. It's just calculations now. The main thing is done. Right, Samyak. Let's see. So I'll just get the x coordinate, right? So x center of mass will be m1, which is sigma into L square minus A square into L by root 2 minus A root 2 plus m2, which is sigma A square into L minus A by root 2 by total mass m, which should be 0. So sigma goes off, and if you try to solve this, you end up with L square minus A square by L minus 2A by root 2 minus A square into L minus A by root 2. So let's simplify this. This is L minus A into L plus A, L minus 2A is equal to A square L minus A. Root 2 goes off, L minus A also goes off. L square minus 2A square minus AL minus 2AL is minus AL is A square. L square minus AL minus 3A square. How did I go up here? This is plus, no? There, then it is just a root there. So L is equal to a plus or minus b square 4a square by 2. Take out a common. We get L by a is 1 plus root 5 by 2. It can't be negative since you're asking for a by L. 2 by root 5 plus 1. You can factorize this. You could have found a ka root actually. That will be root 5 minus 1 by 2. Clear with this? All clear how we did this? This is how they can ask cavity questions. Every time it won't be square and circles. Let's see one more like this. We got a square plate and someone removed a triangle from inside. This height is h and this base is L. Isosceles triangle basically. Square plate of side L. Same thing. If A is the center of mass, find L by H ratio. One. What is that? Which language you're typing, Shaurya? Do you guys remember what is the center of mass for a triangle? Centroid. For an isosceles, where is the centroid? 1/3 of the height from the base. Okay, Shaurya got some answer. 1 plus root 3. Let's see if anyone else got that. I don't know the answer. One plus root 3 by 3. Okay. We have two different answers. But think about that, Anvita, then didn't you get less than 1? Let's see. Again, you can clearly see here the center line is the symmetry. So I will choose this as my origin. You can take anything. I will prefer this as origin because I don't know, center looks a little confusing here for me. Then this center of mass will be 0, h. This is the center of mass of the thing after removing it. This plus you're going to add this triangle. This would be the centroid, center of mass, which will be h by 3. So 0, h by 3. Because for a triangle, the centroid, isosceles triangle this is, so centroid will be 1/3 of the base. When I combine these two, I will get my square plate whose center of mass is this, which is 0, L by 2. That was the center of mass. So the center of mass of this plus this should give me L by 2. Again, if you see, the theme is still the same. X coordinate will be 0. I'm taking that point as an origin. Let's find the masses. So this mass will be sigma into L square. This is L. So this mass will be M2, which is sigma. Area of a triangle is half base into height. This will be M1, which is sigma L square minus sigma LH by 2. The y center of mass will be M1, which is sigma L square minus sigma LH by 2 into H plus sigma LH by 2 into H by 3 by total mass sigma L square. Now this time it is not 0, this is L by 2. Check the equation, everyone. Anything you're not clear here, please ask. Now can we simplify? I'll give you a minute. This is the story every time. Choose your appropriate origin somewhere where you're convenient. Find the masses, find the center of masses, and just finish it off. So sigma cancels off. You end up with L square H minus L H square by 2 plus L H square by 6 is equal to L cube by 6. L also goes off. We get LH. This will be minus LH by L goes off. So this will be H square by 3 is equal to L square by 6. This would be L square minus 6LH plus 2H square is equal to 0. L will be 6H plus root over 36H square. I'm getting a strong feeling I goofed up somewhere. Did I mess up some calculations anywhere? That is 44 numbers are bad. I messed up somewhere, I guess. Can someone figure out where I messed up? Or am I right? L square H minus L H square by 2. Half minus 1 by 6 is Why is that L cube by 6 on the right hand side? That is L cube by 2. How much will that be? 4, 3, 12, 12 minus 8, 4. 2 will cancel 1 by root 3. 1 plus root 3 by root 3. Check your answer. Clear with the steps. Check it out. These questions are more of math based. Any doubts on the calculations? How did I take the mass? How did I get the coordinates? Why I took the origin like that? You want, you can take the origin this corner also. It works. You got to take the origin at the center also. Then this coordinates will be h minus L by 2. That is also fine. It works however you want. For some reason, the moment I saw, I felt that origin would be good. So it's just a choice. All clear with this? That's how you calculate center of masses for different shapes. The next thing is the motion of center of mass. Even though the center of mass is hypothetical, it has its own motion and everything. We know our center of mass is sigma mi Ri by sigma mi. If you differentiate with respect to time, yeah, just give me a minute. So if you differentiate this with respect to time, this will become velocity of center of mass dr by dt v center of mass sigma mi dri by dt sigma mi. You get velocity of center of mass sigma mi vi by sigma mi. The formulas will look same. You're just replacing r with velocity. And if you actually expand this, you will notice something. Sigma mi v center of mass sigma mi vi. This will be the total mass into velocity of center of mass m1 v1 bar, m2 v2 bar, so on till mn vn bar. This is nothing but, if you can clearly see, momentum of the system is actually momentum of the center of mass. So let's say there are 1,000 particles, each one is going with different speeds and different masses. But if you know the center of mass value and if you know the mass of the value, so if you can just find the momentum of the center of mass, it will be the momentum of the system. And this is what I said, that center of mass is simply a point where you can replace the entire mass. So even if 1,000 particles are going in different directions, it doesn't matter. You can just find the center of mass and it works. If you differentiate this again, we get acceleration of center of mass. This will be sigma mi dvi by dt by sigma mi. Acceleration of center of mass is sigma mi ai by sigma mi. And now if you try to expand this, sigma mi a cym, which is m1 a1 bar, m2 a2 bar, so on till mn an bar. This will be total mass into acceleration of center of mass. This will be simply f1 bar plus f2 bar, so on till fn bar. And if you add this, you end up with F external. If you add all the forces acting on the particles, we get F external is mass into acceleration of center of mass, which is a Newton's second law of form. Is that making sense? So this is what we are doing till now. Before center of mass chapter, let's say if there is a a rod is there or a body is there or 10 particles are there and you treated them as one system. When you wrote F is equal to ma, the a belongs to which point? So if I take, let's say, some weird amoeba shape on a smooth surface and you're applying force F. When you're writing F is equal to ma, right, and this amoeba shape, right, might be rolling also and going also. So when you wrote F is equal to ma, that a belongs to what? Is it the acceleration of the point where you applied the force? Is it the acceleration of the topmost point or the midpoint? There's no midpoint here. The bottommost point, which point are you talking about? So that acceleration which you have taken till now was the center of mass acceleration. Are you getting this? So this equation which you wrote is F net is equal to mass into center of mass. So be careful. On a body, different points will have different accelerations. But when you write F is equal to ma, you're writing for the center of mass. Now we go in the reverse. Now listen to this thing. How did we get center of mass ka formula? F is equal to ma, which can be written as F1 plus F2 plus Fn, which is equal to ma cum, which is m1 a1 m2 a2 m1 an. We get a center of mass is sigma mi ai sigma mi. Instead of differentiating, integrate. If you integrate, then you get velocity of center of mass. If you integrate again, you get position of center of mass. Are you getting it? So center of mass is actually derived from Newton's second law. Understood what I did? I differentiated twice, I got second law. If I integrate twice, second law becomes the center of mass. So this center of mass didn't come out of thin air. We actually derived it from the second law. Hope this is clear. And now, if F external is 0, that means on the system, if there are no external forces, then acceleration of center of mass is 0. Implies velocity of center of mass is constant. If velocity of center of mass is constant, therefore momentum is constant. This is our second conservation, everyone. The first was energy. This is called law of conservation of linear momentum. When can you conserve energy? When work done by force is 0. When can you conserve momentum? When the external force is 0. This is your second conservation. You can apply this whenever the external force on the system is 0. Any doubt so far? So we can write like this. Let's say if F external in a particular direction is 0, maybe the total force is not 0. Maybe let's say in x-axis mein net force is 0. If F external in a particular direction is 0, then momentum in that direction is conserved. If the total force is 0, then momentum in any direction is conserved. So whenever you want to use conservation of momentum, you need to ask, are there any forces in the system? If there are no forces in a particular direction, in that direction you can conserve momentum. Second thing, internal forces do not affect the center of mass. Why? Internal forces will cancel out. So if you take a bomb and if it explodes because of internal forces. Center of mass doesn't get affected. That is, it will continue to move with a constant velocity. We'll talk about this later on. Meaning, think about this. Let's say your car stopped working for some reason. So you're sitting in the car. If you sit in the car and if you push the car from the back seat, will the car ever move? You might be thinking, right, you're helping by pushing the seat, but you're sitting in the back seat and you're pushing the front seat. The car is never going to move. It's like your internal force. Or you can try this thing with your left hand, catch your right hand and try to pull yourself in the forward direction. If you catch your right hand with your left hand and try to pull yourself ahead, not going to happen. Momentum of a system with respect to center of mass, if you take an observer and make him stand on the center of mass, and if you ask him what is the momentum of the system, just now we said, what is momentum of the system? Momentum of center of mass. Now, if you go and stand on center of mass, you will think center of mass is always at rest. The momentum of the system with respect to center of mass is always 0. Because if you go and stand on center of mass, you think you're never moving. Therefore, we get a very important derivation. Momentum is always conserved in the center of mass frame. This is how they ask theoretical questions. Even if there are external forces. Generally, if you have external forces, you can't conserve momentum. But center of mass is one special point. If you go and stand there, the momentum is always 0. Right? So have a look at this. Let's take a break for 5 minutes, then we'll continue from here. Any doubts so far? Come back in 5 minutes. Let's start off. These two are important statements. And if you look at this, the center of mass can be treated like an independent particle. So if you want to find acceleration center of mass, you can just differentiate the velocity of center of mass. Or you can write this thing as velocity of center of mass, dv center of mass by dr. And suppose if A center of mass is constant, you can even use your kinematics equations. So everywhere it just becomes center of mass, center of mass. There. So everything works. Clear with this? Let's see a question. We have two particles here, mass m, projected with 20 root 2 meters per second, angle 45 degrees. We have another particle mass 2m, projected with a speed of 25 meters per second, angle 37 degrees. Let's call this particle as A, let's particle B. Find the velocity of center of mass at time t, acceleration of center of mass, h max of center of mass. So there are two particles A and B of mass m and 2m projected with speeds and angles as shown. So if these two particles are flying in the air, their velocity of center of mass will be something at time t. Find the velocity of center of mass, acceleration of center of mass, and maximum height of the center of mass. Let's get that. I think so, Samyak. Let's see. Anvita, I'm asking as function of time t. Initial velocity nahi hai. I would have written u, na, then. I didn't ask you initial velocity of center of mass. I want velocity of center of mass at time t. Maybe I'll write that if you want. Find velocity of center of mass at time t. One more minute. Let's give it a try, everyone. नहीं हो गया. Again, I think you're finding initial, I guess. I want you to find as function of time t. So how do you do? Let me show you one. Let's resolve the velocities. Initial velocity of A, 20 I cap, 20 j cap, cos 45, sin 45. Velocity of B, 25 cos 37. Cos 37 is 4 by 5 minus 20 I cap. 25 sin 37 is 15 j cap. Perfect. So what is the initial velocity of center of mass? M into 20I plus 20j. Don't forget the mass is double. 2m into minus 20I plus 15j by total mass, which is m plus 2m. This will be 20 minus 40 minus 20 by 3 I cap. 20 plus 30, 50 by 3 j cap. This is your initial velocity. Remember, this is your Vx component. This is your Uy component. Perfect. What about the acceleration? Acceleration of A is minus g j cap. Acceleration of B is also minus g j cap. Therefore, acceleration of center of mass is also minus g j cap. You got everything basically. So what do you want to find? Velocity of center of mass. So Vcym is the initial velocity of center of mass plus acceleration of center of mass into time t. Substitute here. This will be minus 20 by 3 I cap plus 50 by 3 minus gt j cap. That's your velocity. What do you want to find? H max? What is H max? U y square by 2 ay. What is uy here? 50 by 3. This is what I said. The center of mass itself will behave like a new particle whose velocity is 50 by 3 in the vertical direction. 50 by 3 whole square by 2, acceleration is g. That's 2500 by 9 into 2 into 10. That's 125 by 9 meters. Clear with that? So once you find the initial velocity, you can treat like a particle which is thrown with a speed 50 by 3 and minus 20 by 3. And you can finish off. Check it out. Right, Samyak. Any doubts on this? Let's see one more. It's an easy one. This is a PYQ. We have block M and block 2M Atwood machine. Release from rest. Find acceleration center of mass. Yeah, g by 9. We know the acceleration, so this will go up with a and this will come down with a. Hope you remember the thing. m2 minus m1 by m2 plus m1 एटवुड मशीन का फॉर्मूला. The most common mistake, right? People think both are g by 3, but they forget the sign. This is g by 3 j cap. This is minus 3 by 3 j cap. Minus g by 9 j cap, it goes down. That's it. Straightforward question. Easy one. Next one. This is the top view. We have a circular track and we have a toy train. We have a semicircular toy train. Meaning this train, right, occupies half of the track. And the train is going with a constant speed u. Mass is m. Radius is r. So semicircular toy train moves in a circular track with a constant speed u. Find the velocity of center of mass. They can ask you find the momentum of the train, find the velocity of center of mass, and acceleration of center of mass of the train. This is again a good one. These are proper mains level questions. This and the previous one. Right, Samyak. 2 pi u r square. I don't know, Srihari, what you wrote. I don't think so. Let's see. Now, most people think that everything is going with constant speed. So why the answer is not you? You're forgetting something. Every point on the train is going with different velocities. You cannot add all the velocities directly. You can't add, you cannot add I plus j cap, isn't it? I plus j is not 2. So how do we handle this? So there is a neat trick here. Since the train is a semicircle, the center of mass of the train will be at a distance of 2r by pi. Agreed? The center of mass of a semicircle. If the train goes with a constant speed u, then the center of mass also will go in a circle of 2r by pi. Agreed? If the train is a semicircle, the center of mass of a semicircle is 2r by pi. If the train is going in a circle, the center of mass also will go in a circle. So can someone tell me what will be same for the train and this thing? They will have same omega, isn't it? The time taken for one completion for a train will be the time taken for one completion, circle completion of the center of mass. The center of mass and the train will have same omega because they complete one revolution same time. They don't have same speeds. So you're done. So what is omega? U by r. So what is velocity of center of mass? Distance of center of mass into omega. 2r by pi into u by r. 2u by pi. That is the speed of the center of mass. The center of mass itself will go in a smaller circle. What is the acceleration of center of mass? Something is going in a circle, then we'll have centripetal acceleration. V center of mass square by r center of mass. So V center of mass square will be 4u square by pi square. And r center of mass will be 2r by pi. So that will be 2u square by pi r. Check. Right here, you got the speed. All clear with this? So the other way to do is integrate. But if you can realize every time the train goes in a circle, the center of mass will be a semicircle. It's easy to realize that. Any notes on this? Let's see one more. This is another easy one. We have an explosive bomb of mass m at the origin. Explodes into three pieces of mass m by 4, m by 4, and m by 2. One m by 4 moves along x-axis with speed u. Another m by 4 moves along y-axis with speed u. Find the velocity of m by 2. Find velocity means I want the vector form. So initially the bomb is at rest, it explodes. You get three pieces, m by 4, m by 4, and m by 2. One m by 4 goes along x and another m by 4 goes along y. And what is the velocity of m by 2? Get this as an easy one. Let's see. Now we are slowly entering into the center of mass thing. So when the bomb explodes, the forces are internal. Explosion is due to internal forces. Therefore, F external is 0. Therefore, momentum is conserved. So how to use conservations? Just like energy, define your states, state 1, state 2. So initially, the explosive is here at rest. So initial momentum, Pi, is 0. After explosion, one m by 4 is going with U, another m by 4 is going with U, another m by 2. We don't know how it is going, let it be velocity V. Initial momentum is equal to final momentum. Initial is 0. M by 4, U I cap. Vectors, everyone, momentum is a vector, unlike energy. M by 4, U j cap. M by 2, V bar. M goes up everywhere, and then you end up with V bar is equal to minus U by 2 I cap plus j cap. That's your answer. Easy? Any doubts on this? Utsa, keep your cams on. Vedika, Vanshika. Next one. Potential energy of center of mass. So let's say if there are n particles, m1, m2, mn, so on, and let's say they're at a height of h1, h2, hn. What is the potential energy of the system? Potential energy of the system, you just add the potential energy of each and every particle. m1 g1 h1 plus m2 g h2, so on till mn g hn. If you take out g common, this will become simply sigma mi hi yi. But sigma mi vi is nothing but capital M into y cym, isn't it? That was the definition of center of mass. And if you remember, y center of mass is sigma mi yi. Sigma mi is the total mass, so y center of mass. So potential energy of the system is potential energy of center of mass. Same thing. If there are 1,000 particles, you need not worry how is the momentum of each one. You can just find the center of mass and finish it off. Example, let's say if you have a solid cone, and if they ask you to find the potential energy of this cone, you can clearly see every particle is at different height, but the center of mass is at h by 4. Taking the ground as a reference line, the gravitational potential energy will be mg h by 4. Means you can replace this entire cone at a height of h by 4 and finish it off. Clear with this? So till now, if you see, right, momentum of the system is momentum of center of mass. Kinetic energy of the potential energy of the system, potential energy of center of mass. Because of this, you might start thinking kinetic energy also will be like that. Unfortunately, it is not. So this is one important thing. Kinetic energy of the system need not be equal to the kinetic energy of center of mass. So let's see what will be the value then. Let's say I have particle M1 going with V1, M2 going with V2, Mn going with Vn. What is the kinetic energy of the system? Kinetic energy of all the particles. Sigma half Mi. This derivation is important. We're going to see this again in rotational mechanics. You're going to use this directly. Velocity of I with respect to the ground frame. Take what half outside. This can be written as sigma Mi. Velocity of I with respect to ground can be written as velocity of I with respect to center of mass plus velocity of center of mass with respect to ground ka square. Expand this. This will be Vi center of mass ka square. V center of mass with respect to the ground ka square plus 2 velocity of I with respect to center of mass dot velocity of center of mass with respect to ground. When you multiply this, you will end up with sigma Mi V center of mass square, sigma Mi Vi center of mass square, sigma Mi Vi center of mass. Now, if you look at each term here, especially look at this term here, what is this? M into V is momentum. This is the momentum with respect to center of mass because you're taking velocities with respect to center of mass. And just now we showed momentum with respect to center of mass is always 0. So this third term actually becomes 0. And you'll end up with something interesting. Half Mi will be the total kinetic energy of center of mass plus this is the kinetic energy I with respect to center of mass. So kinetic energy about center of mass. So kinetic energy of the system is not equal to kinetic energy of center of mass. Means find the center of mass velocity, find the kinetic energy. Then go and stand on the center of mass and then find the kinetic energy. If you add both of them, that will give you the total kinetic energy. So momentum of system is momentum of center of mass. Potential energy of system is potential energy of center of mass. Kinetic energy system is not equal to kinetic energy of center of mass. Now, if you notice in all these equations, this will be a very useful concept. Later on, we're going to use this concept again in fluid mechanics, electrostatics, magnetism. We're going to use it at least in 3 places. So what is the thing? Tell me one thing. Momentum, potential energy, center of mass system is equal to center of mass of the moment. Momentum of the system is momentum of center of mass. Potential energy of the system is potential of center of mass. Kinetic energy, it is not. What is the difference? What is there in this? There is something common there, and there is something not common here. Then, can anyone think about what is common? It worked for center of mass and momentum. It didn't work for kinetic energy. So what is common between center of mass and momentum? Mathematically. I'm talking about mathematically. Look at momentum. M into V power 1. Potential energy. Mg H power 1. Kinetic energy. Half M V square. These are linear functions. Kinetic energy is a square function. So keep this in mind. Center of mass is a very useful concept. If the function is linear, you can use center of mass. So whenever the function is linear, center of mass works. Just you will forget the statement anyways. When it comes, I'll show you. Then you will be in a shock. For example, see, how does this previous formula work? Let's say I have a body here, mass with 2m, going with v. Let's say I have another body m going with v. Right? So center of mass will be somewhere here. What is the velocity of center of mass? 2m v I cap plus minus m v I cap by 3m. This is v by 3. Now, if you go and stand on the center of mass, so your center of mass itself is going with v by 3. So center of mass will think this block M is coming with 4v by 3. And this center of mass will think the 2m is going with 2v by 3. So kinetic energy of center of mass, meaning you treat the center of mass like a particle, is half into total mass is 3m v COM square, which is half 3m v by 3 whole square. This is mv square by 6. Kinetic energy about center of mass, meaning you go and stand on the center of mass and then find the kinetic energy. That will be half m 4v by 3 whole square half 2m 2y by 3 whole square. Now, this equation says the kinetic energy of the system. If you add these two, then you will get half mv square plus half 2mv square. So kinetic energy, unfortunately, doesn't work. It's a simple example. You could have done it normally, but yeah. Clear? Next thing. Let's see a question based on this. Is 89. Clear? Let's say we have three shapes. We have a cone. We have a solid sphere. And we have a solid cylinder. This is 2r. Height is also 2r. Solid sphere 2r. Basically, the radius is 2r. Our radius is r. Cylinder 2r. 2r. Take the ground as reference line. Find the ratio of gravitational potential energy. All are made of same material. So we have a solid cylinder, solid sphere, and solid cone of same height. Find the ratio of gravitational potential energy. 1:2:2. That is wrong, Srihari. Right, Samyak. Right, Shaurya. Ne Vansh. Ne Utsav. Ne Ishman. I hope you guys are considering the masses also. Let's see. Where is the center of mass? For the solid cone, the center of mass will be h by 4, but h is 2r here, so r by 2. Here the center of mass is r. Here the center of mass is also r, the midpoint. Perfect. So what is the potential energy? mgh. What is m? Density, volume 1 by 3 pi r square, height is 2r. Mass, gravity, h of center of mass is r by 2. mgh. I hope you're getting what I wrote there. Is to rho solid sphere 4 by 3 pi r cube. M G height is r. Solid cylinder rho pi r square h is 2r. G height is r. You can clearly see here rho goes off 1 by 3 pi r cube. G r r rho pi r cube 3 G r rho 3 doesn't go off actually. Rho pi r square r G r rho pi r square r rho pi r square r. Then we'll be left with here 2 to 1 by 3, 4 by 3, 2. 1 is to 4 is to 6. Check. Right, Utsa. Clear with this thing. Masses, you have to be careful. Potential energy of the system. So mgh, m and h both will change. All clear with this? Next one. We have a table here. We have a chain here. 1/3 of the chain is hanging from the table. Find the work done to put the hanging chain back on the table. So how much work should you do to put the hanging chain back on the table? Chain-based questions. The second question, we have a semicircular pipe and inside there is a chain. Initially it is at rest. Someone gave a gentle disturbance and the whole chain started coming out. Find the speed when the chain completely comes out. Yeah, previous answer is 146. Most of them got it. So please check your calculations. Get them both. Finish off. Last two for the day. First was easy. Both were asked at a mains level questions. These are. Let's see the first one. This is straightforward. So you want to put the chain back on the table, meaning the picture will become like this. So where is the centromus for the chain? At the center. You're getting it? For the hanging part, it's like a rod. The centromus for a rod is a center, which is L by 6. What is the mass of this chain part then? M by 3. Because of the total length is L, mass is M. So the potential energy of the hanging part will be M by 3 G L by 6. MGL by 18. So this much work should you do in order to put it back. Easy. I think the mistake is some of you didn't take the mass. You took mass as M. It is M by 3, isn't it? You want to put only the hanging part back on the table. So the question has become like this. So you have taken this center of mass here at a height of L by 3, mass M by 3. You took this and put it back on the table. That is how you can think of. Easy. What about this guy? This is a good one. Pi plus 4 by pi, I don't, maybe it could be right. Let's see. Try, others, I'll give you a minute. So initially the chain was a semicircle. When the chain came out, it became a rod, it became a straight line. So think the center of mass ka thing changed. Same story, loss in potential energy is gain in kinetic energy. Let's see. This is my state 1. This is my state 2. Initially, where is the center of mass? Center of mass is here. Height of 2r by pi. So potential energy, I am taking this line as a reference. Potential energy mg, height of the center of mass 2r by pi. Kinetic energy 0. when the chain comes out, what is the length of this chain? The length of this chain is the semicircle ka circumference pi r by 2. That means the center of mass will be in the midpoint here, which is pi r. So that means the center of mass will be somewhere here, which is pi r by 2. What is the gravitational potential energy? Minus mg pi r by 2, because you've gone down by this height. What is the kinetic energy? Half mv square. So you can actually argue like this. The center of mass has gone down from 2r by pi to minus pi r by 2. So since there are no external forces, energy in state 1 is equal to energy in state 2. mg 2r by pi minus mg pi r by 2. There you can use center of mass and work energy theorem, work power. So you end up with V is equal to root over 2g 2r by pi plus pi r by 2. Check. That's your answer. So the semicircle, whose center of mass is 2r by pi, it became a vertical line. Just give me a minute, let me take the attendance. Half of the people left for some reason, not sure why. We will just call up them and ask the parents. Anyways, so that is one. Okay, with that, we'll wrap up for the day. Next class, when we catch up, we are going to do more based on momentum and everything. And next week, we are on a break because of